Hi guys, welcome to your day 7 notes where we're going to talk about area of a triangle, but in terms of trigonometry. So this will allow us to find the area of any triangle as long as we know two sides and the included angle. So just as a little refresher, we know that the area of any triangle is equal to 1/2 base times height. So in our first triangle, this is equal to 1/2 times 5 times 12. 5 times 12 is 60. Half of that is 30. I knew I had the base and I had the height because they were meeting at 90 degrees. For the next example, the base is 20, the height is 8, so area would equal 1/2 base times height. So half of 20 is 10 times 8 is 80. And as soon as you get over to our third triangle, that's where we run into a little bit of an issue. I don't know the angle H is a right angle, so I can't assume that there's any sort of relationship to find a height there. Additionally, there's no altitude even listed here. Like if they had this altitude drawn in through H and I knew that height, then perhaps I could find the area of the triangle, but I don't have that. So that's where our trigonometry formula will come into play. So the trig formula for area of a triangle is given here. Whoopsies. Start to move it around. Given right here. Now you'll notice that we say K instead of capital A for area, just because capital A actually represents an angle in our triangle. That would be angle A over there. Okay. Now, area will equal 1/2 side A times side B times the sine of our included angle C. So this is your general formula for the area of a triangle. I could technically use side C and side A with respect to angle B. I could also technically use side C and side B with respect to angle A. So as long as you have two sides and you know the included angle, you'll be able to find the area of a triangle. So why does this work? So starting down below in this picture, I want to find the area of this triangle. Now I'm going to start off by finding the sine of angle C. So I will be focusing on this right triangle right here. Now we know that sine is equal to opposite over hypotenuse. So from angle C, I'm seeing the opposite side is H, and the hypotenuse would be side B. Now with a little bit of rearranging, so I can do a little bit of cross multiplying here, I can see that 1 times H is H, and B times sine of C is just B sine of C. Okay, so H, this height, is equivalent to side B times the sine of C. Okay. Now our base of our whole triangle here is just side A. Now if we know that area is equal to 1/2 the base times the height H, I know the base of this triangle is A, and the height I just found to be equal to B times the sine of C. And that's how we end up with area equals 1/2 AB sine of C. And that'll allow us to find the area of this whole triangle. So let's put that into practice. Okay, so just like I mentioned on the previous page, guys, there's actually 3 different formulas here. This one you're going to see me write the most. That's just like our general formula in terms of angle A. Okay. We also have the formulas in terms of angle angle C. Ooh, the first formula is 1/2 AB sine of C, so that's your formula in terms of angle C. You also have the formulas for in terms of angle A as well as angle B, so either one of those two. But most of the time you're going to see me just use the first one. Okay. So starting with question 1, it says find the triangle of area of triangle BAD if BA is 8, AD is 6, and angle A is 150. So let's draw a picture. So I know that angle A is 150, BA is 8, and AD is 6. Okay, so area, oops, ignore that. Area, which I'll use K, is equal to 1/2 AB sine of C. And again, this is your general formula. It's not going to necessarily correspond to the letters that I have in my picture here. Technically, the letters I would be using are B and D for the sides. Okay, so these are the sides that include the angle. So whichever way you want to do them, 8 and 6 or 6 and 8. Angle C is the angle in between those sides. So now we just plug it in. So area equals 1/2 AB sine of C, and that's where we go to our calculator. Try to make this a little bit smaller. There we go. All right, so just like usual, make sure you're in degree mode. So I'm going to go ahead and type in 1/2, 1/2 times 8 times 16, or times 6, excuse me, times the sine of 150. And then I hit enter. And there you go. So that means the area of our triangle is 12. So 12 units squared. And that's how it works. All right, let's go to the next guy. Okay, so given triangle ABC, AB is 6, BC is 9, angle A is 60, and angle C is 80. Find the area of triangle ABC to the nearest tenth. All right, so I'm going to draw a picture again. ABC, angle A is 60, angle C is 80. I know that AB is 6 and BC is 9. Okay, so when I look at my picture, I'm noticing that I have sides 6 and 9, okay? Now, what's important to note is you do not have the included angle here. You are missing angle B, and that's going to be crucial to finding the area of the triangle. Here's the good news, though. Can't you find angle B? You know that between 60 and 80, you have 140 degrees, which means that missing angle B must be 40 degrees. Okay, I'm going to write that again so it looks a little bit nicer. 40, whoop, if it lets me. I'm not using my usual stylus today because it died. So it's just like not wanting to work for me today. There we go. Okay. So now that we have our included angle and the two sides that include it, we can go to our formula. So area equals, I'm just going to plug in the sides. So 6 times 9 times the sine of our included angle. And now we jump to our calculator. So 1/2, 6 times 9 times the sine of 40. So 17.4 to the nearest tenth. There you have it. All right, number 3. Given below is a depiction of a triangular park formed by the intersection of 3 streets, Maxwell Road, Harley Ave, and Lolo Drive. It is known that Maxwell Road is 220 feet long. I'm actually going to include that here, 220. If Maxwell and Harley intersect at 76 degrees, put that in there, and the area of the park is given. Okay, so they're telling you that the area of the park is that 16650 number. Determine to the nearest integer the length of Hartley Ave. All right. Okay, so we know that the included angle is 76, and we only know Maxwell Road, which is one of the sides that includes that angle, so that's 220. We also know that the area of the triangle, which is our park, is given. All right, so we know, oh, geez. Apologize again, my stylus is just not working right now. All right, so area equals 1/2 AB sine of C. Okay, I know the area, so let's plug that in. I know one of the sides, which is 220. The other side I'm going to call x, and we know the included angle is 76. All right, so we need to solve for x, which is right here. So what I'm actually going to do is clean up that right-hand side. I'm going to type in my calculator 1/2 of 220 times the sine of 76. Okay? And I get this 106.73 number. Okay, so in order to solve for x, because everything's just being multiplied together, guys, we would have to divide both sides of our equation by that 10, was it 106 or 1? Yeah, 106 number. I wrote that wrong, so it's 106.73. Excuse me, sorry, I messed that up. I'm going to fix that. 106.73. All right, so we're dividing both sides by that. All right. And I'm just doing dot, dot, dot there so you guys know I'm doing the full decimal. So go to my calculator. I'm going to type in our area, 16650.27 divided by, and I can go up and grab that 106.73 number. Okay, so 155.9 repeating, which to the nearest integer would be 156. And that will be our final answer. Okay, so in that problem we didn't find the area, but we used the area to find a missing side length. All right, let's go to the next page. Okay, what about the area of a parallelogram? Well, guys, a parallelogram is really just two triangles. So if I draw on the diagonal, that means I have two sides that include an angle. Now, in this problem, they're telling me the area of the parallelogram is 50, so that means each half must be 25. So now we're in a similar place that we were in the last problem. I know the area is equal to 1/2 times the sides times the sine of the included angle. And now we just have to solve for x. Okay, so just like the last problem, I'm going to go ahead and type in 1/2 8 times the sine of 100. Okay, and I get this 3.93 number. Times x, right, equals 25. So in order to solve for x, we would just divide by that number. So to the nearest tenth, we're getting 6.3. And then we're done. All right, what about the area of an equilateral triangle if the measure of one side is 4? Well, in an equilateral triangle, we know that all the angles will have to be 60 degrees because all the sides are congruent. So it really doesn't matter what side you pick or sides you pick because all of them will end up being 4, right? So the area of our equilateral triangle, we'll just use any two sides, and then no matter what, the included angle will be 60. So area equals 1/2 AB sine of C. So our area is equal to 1/2. One of the sides is 4, the other one is 4 as well, times the sine of 60, and then we just go to our calculator. So to the nearest, what was it? Thousandth, so tenths, hundredth, thousandths, that's 3 decimal places. I'm getting 6.928. And that's your final answer. All right. So next and last question of our notes is how to find the area of our hexagon, which you guys are seeing below. So they're telling us that the hexagon has a radius of 6. We want to find the area of the hexagon to the nearest hundredth. All right, guys, so this is actually going to look similar to what we discussed earlier in Unit 10, where I can create more little triangles in here and recognize that there are 6 triangles here. So if the radius is 6 there, it must be the radius of 6 here as well. Okay, and the central angle must be 60 because 360 divided by 6 is 60 degrees. All right, guys, so I am seeing 6 triangles that we'll find the area of, but really what I'm going to do is find the area of one of them and then just multiply by 6. All right, so area equals 1/2 AB sine of C. Okay, so whatever that ends up being, just keep in mind that's the area of one triangle. I need 6 of them in order to get the hexagon. So actually, I'm going to jump to my calculator right away. I'm going to type in, okay, 1/2 times 6 times 6 times the sine of 60. Okay, so 15.58, whatever, okay, that's typically what students will write if it's a wrong answer. That's close, but not quite. So it's this 15 number, but remember times 6 because you need 6 triangles to make up the hexagon. So to the nearest hundredth, we would have 93.53 as an answer. And that's your area. Okay, now technically you could also actually calculate the height of this or the altitude of one of those triangles, find the area of the triangle using 1/2 base times height and then multiplying by 6, but honestly it's a little bit harder. You'd have to use either special right triangle rules or trigonometry. This is the easiest way to go about doing it. So this formula is super awesome just because, again, you don't need the height of a triangle in order to find the area. You just need 2 sides and the angle in between. Okay? So write it one more time. K equals 1/2 AB sine of C. That 1/2 turned out a little bit messed up. Okay? Where again, AB are the sides and C is the included angle. All right, thanks for watching the video, guys. I would like you to submit in Google Classroom with your homework so that I know you watched this video all the way to the end. I want you to draw a star next to your name when you submit your homework for this lesson. All right, have a great day.